Yes, good morning, my dear children, all of you. Today we are going to discuss the concepts of exercise 2.3. Is the screen clear to all of you? Yes, okay. Now, in the previous exercise, we have discussed relations and we have discussed what is domain, what is codomain, what is the range of a relation. Here, functions, it is also a one special kind of relation, a special kind of relation. Not every relation is said to be a function. Only particular types of relations, only particular types of relations are called function. What is the condition? What is the condition? A relation to be a function. Okay, my children. And we discuss domain, range of a function and codomain of a function, and what is real valued function and what is real function, and graphs of some real functions. We discuss these points today. Now come to a function. What is meant by a function? First I will write the definition of a function and I will explain the definition by taking some examples. First of all, I'm writing the definition of a function. A relation a relation F from a set A to a set B to a set B is said to be a function if every element of A has one and only one image in set B. This is the first definition of a function. A relation F from A to B is said to be a function if every element of A has one and only one image in set B. To understand this definition, let us take an example. Let us take an example to understand this definition well. Okay. Now observe the arrow diagram. What is this diagram called? Can you tell me what is this diagram called? What is this diagram called? Yes, arrow diagram. Very good, my dear Percy. All of you remember this point, my dear children. This is not Venn diagram, arrow diagram. Okay. If you observe this arrow diagram, Suppose this is a relation F. AF is a relation defined from A to B. Now let us check whether this relation F is a function from A to B or not. To check that point, we have to see two conditions. The first condition is every element in the first set, every element in the first set should be connected with should be connected with one and only one element. One and only one element. Every element in the first set should be connected. That is first point. And second point, that element should be connected with one and only one element. Means every element in the first set should have one and only one image. How many images has? What is the image of one? Tell me. What is the image of one here? What is the image of one here? Yes, very good, my dear Ria. What is image of two? What is image of two? Yes, very good. What is image of three? Yes. What is image of four? Very good. So if you observe, every element in the first set has one and only one image, not more than one image. Yes or no? These two conditions should be satisfied. First of all, every element in the domain, every element in the first set should be connected. That is first point. No element should be left here. No element should be left here without any connection. And the second condition, every element should have one and only one image. Means we should draw only one arrow from every element in the first set. So this is a function. Now observe this arrow diagram, my dear children. Observe this example 2. Here F is a relation defined from C to D. C to D. Then is it a function or not? Is it a function or not? What I said, the first condition is every element in the first set. Every element in the first set should be connected with elements in the second set. If you observe this arrow diagram, or every element in the first set is connected with the elements in the second set. Which element is not connected? Which elements are not connected? Yes, very good, my dear Ria. Very good. Very good observation. Here 4 is not connected with any element in the second set. Yes or no? This element 4 is left over, which is not connected, which is not associated with any element in the second set. Therefore, here F is not a function, because See here, I wrote the reason also. F is not a function because the element 4 in the first set is not connected, is not connected, does not have any element. Okay, is not connected with with any element, with any element in the second set. Here this is not connected with any element in the second set. So this is not a function. This is only a relation. This is only a relation. And another example, I will take another example. Now observe this arrow diagram, my dear children. If you observe this arrow diagram, this is also a function defined from set E to set F. Now let us check whether this is a function or not. Is this a function or not? It is not a function. This is not a function because here, if you observe this arrow diagram, if you observe this arrow diagram carefully, here the element 3 in the first set, the element 3 in the first set is connected with two elements in the second set, namely yz. Means the element in the first set has two images. Previously, what we have discussed, every element in the first set should have one and only one image. It should not have more than one image. Okay, my children. So here, this condition is not satisfied here. Of course, every element in this first set has image. Every element in the first set has image. But in the case of element 3, in the case of element 3, it has two images. It should not be happened. It should not be happened. That is why this is only a relation. This is not said to be a function. Here, f is not a function because it should have one and only one image. It should not have more than one image. Understood these two conditions, my dear children? Every element in the first set should be connected. Means every element in the first set should have image, and moreover, it should not have more than one image. Understood these two conditions, my dear children? By arrow diagram, I have explained which is a function and which is not a function. Understood this point, my dear children? Yes. Now, can you tell me, by observing this arrow diagram carefully, can you tell me, is it a function or not? And justify your answer. Is this relation a function or not? And justify your answer. Nikhil said function. What about others? Mahima, Samuel, Richan, Catherine, Ria, Juice, Percy, Disha Priya, Vinisha, Rexlin. Yes, very good. Except Nikhil, all other children said it is not a function. Why? Can you tell me why this is not a function? Have you observed this arrow diagram, my dear Nikhil, carefully? Have you observed this arrow diagram carefully? Why this is not a function? Yes, very good. -4 here. In the first set, the element -4 is not connected with any element. Means -4 does not have any image. Understood, my dear Nikhil? You have to observe the arrow diagram carefully. Okay. Here -4 is not connected with any element. Means here the element -4 does not have any image in the second set. Here f is not a function because the element -4 in the first set or in the set G. Here first set is G. Name of the first set is G. In the set G is not connected. Understood, my dear Nikhil? Understood, my dear Nikhil? Understood this point? Yes. Now observe this arrow diagram carefully, my dear children. Here G is a relation defined from set to I to set to J. Is this relation a function or not? And justify your answer. Is this relation G from I to J a function or not? Justify your answer. Tell me, my dear. Mahima, Samuel, Richan, Catherine, Ria, Juice, Percy. What about Vinisha not responding? Vinisha is not responding. Yes. Yes. Very good. What about Nikhil? You kept silently, not responded. Nikhil? Yes, it is a function. It is a function because this relation is satisfying the two conditions. What is that two condition? Every element has connected. Every element is connected. That is the first condition. And the second condition, every element in the first set has one and one image, one and only one image in the second set. Yes. SG is a function from I to J. Okay, my children, understood this concept, how to identify a relation is a function or not. In other words, we can define a function like this also. In other words, in other words, a function f is a relation from a non-empty set non-empty set A to a non-empty set B, such that the domain of f is A and no two distinct ordered pairs in F have same image, same first same first element, same first element. This is another definition. Suppose you know that a relation is nothing but a set of ordered pairs. Suppose F is also defined with a set of ordered pairs, then we can check by observing the first elements of the ordered pairs. No distinct ordered pairs should have the same first element. Suppose let us take an example. Okay, my dear Percy. See here. See the definition again. Second definition. In other words, a function f is a relation from a non-empty set A to a non-empty set B such that domain of f is A and no two distinct ordered pairs no two distinct ordered pairs in F have the same first element. Okay, my dear Percy? Yes. Now let us take an example to understand this definition. Suppose that A is equal to set 1, 2, 3, 4, and B is equal to set let R be a relation or R1. Here we have written the relation R as a set of ordered pairs. As a set of ordered pairs. Now, by observing these ordered pairs, here domain of this here this domain of function the domain of the relation R1 is 1 2 3 4 1 2 3 4, and if you observe here, what is the domain of R1? Can you tell me? Can you tell me here what is the domain of R1? Can you tell me what is domain of R1? How do you say domain of R1? Do you remember that definition? Domain of R1. The relation is given as a set of ordered pairs. Then how do you find domain of the R1? How do you find domain of the relation? Anyone? Do you remember that point? The set of all first elements. The set of all first elements. Yes, very good. The set of all first elements in the ordered pairs is a domain. So 1, 2, 3, 4. It is nothing but set A. Yes or no? According to the condition, here domain is set A. And any two distinct ordered pairs have the same first elements. Here 1, here 2, here 3, here 4. If you take any two distinct ordered pairs, they do not have the same first element. Yes or no? Yes or no? Domain of R1 is equal to set first set domain of R1. This condition should be satisfied, and they do not have, and distinct ordered pairs do not have the same first element. That is why here this R1 is said to be a function. I will take another example. Now observe this relation R2. Is this a function or not? And justify your answer. Here R2 is a relation defined from set C to D. Observe these ordered pairs. Observe these ordered pairs. Now tell me, is it relation R2 a function or not? Justify your answer. Mahima, Samuel, Richen, Catherine. Ah, yes, 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 yeah, yes. But here, you should not use this sentence. One is not connected. One is not connected because here we have not shown this relation through an arrow diagram. We have not shown this relation through an arrow diagram. But what is the condition here? First of all, we have to find domain. Domain. Domain of R2. What is the domain of R2 here? The set of first elements. Yes or no? The first elements in the ordered pairs. 1, 0, 3. This is a domain of R2. But this is not equal to first set C. This is not equal to first set C. If a relation is defined as a set of ordered pairs, first of all find the domain of that relation. That domain should be equal to the first set. Otherwise, it is not said to be a function. Here we should not use this word minus 1 is not connected because we have defined the function in the second method, in the other method, set of ordered pairs. So here we are not using connected, not connected. Here domain of R2 is not the first set. Actually the first set is 1 minus 1 0 3, but domain of R2 is 1 0 3 only. Both are not same sets. That is why we can say that here it is not a function. Therefore we have to find domain of the relation. The domain of the relation is equal to the first set. Then we go to the second condition. After this condition is satisfied, then we go to the second condition. What is the second condition? Distinct ordered pairs. Distinct ordered pairs should not be the same first element. That is the second condition. After first condition is satisfied, then we go to the second condition. Remember these conditions, my dear children, carefully. The second condition is then we have to check. We have to check distinct ordered pairs. Distinct ordered pairs should not have the same first element. That is the second condition. After the first condition is satisfied, then we go to the second condition. If the second condition is also satisfied, then only we can say that the relation is a function. Otherwise, it is not said to be a function. Let us take another example. Now observe this example 3, my dear children. Let E is equal to set x comma y comma z comma a comma b, and f is equal to set -1 comma 2 comma -3 comma 4 comma 5 comma 6. Let R3 be a relation defined by R3 is equal to set of ordered pair x comma 2 comma ordered pair y comma 4 comma ordered pair y comma 5 comma ordered pair z comma -1 comma ordered pair a comma 6 comma ordered pair b comma 2. Now observe this relation R3. Is it a function or not? Justify your answer. Yes, my dear Ria. What about other children? Only Ria responded. Betsy, Richan. Yes, Mahima, Catherine. Yes, Nikhil. Yes, Samuel. Disha Priya. What's your answer? Disha Priya. What about your answer? Disha Priya. Why it is not a function? Can you tell me, Disha Priya? Why this is not a function? Why this? She left the meeting. Disha Priya. Anyone justify your answer? Any one of you just raise your hand and justify your answer. What happened, my dear Disha Priya? Justify your answer. Just raise your hand. It's okay, my dear Disha Priya. It's okay. Just raise your hand and justify your answer. Raise your hand and justify your answer because you told it is not a function. Tell me why it is not a function. Why it is not a function? Tell me, Mahima, Samuel, Richian, Catherine, Ria, Juice, Percy, Richlin, Nikhil. All of you said, even Disha Priya, you said it is not a function. Very good. Your answer is correct. Then tell me why it is not a function. Justify your answer. What is the first condition? Tell me. What I said. What is the first condition? Should be checked. Yes. 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 Very good. First of all, we have to find domain. That is the first condition. First condition, we have to find domain. How do you find domain of this relation? The set of all first elements in the ordered pair. X, Y, Z, A, B. X, Y, Z, A, B. This is equal to set E. This is equal to the set E, first set. So this first condition is satisfied. Here, the first condition is satisfied. Now we go to the second condition. What is the second condition? Distinct elements. No two ordered pairs have the same first element. That is the condition 2. That is condition 2. No two ordered pairs. No two distinct ordered pairs have the same first element. If you observe these two ordered pairs here, these two ordered pairs have the same first element y. Yes or no? Ordered pair y comma 4, ordered pair y comma 5. Here R3, here 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 R3 is not a function because here I wrote the reason also. Here R3 is not a function because distinct ordered pairs, ordered pair y comma 3 comma ordered pair y comma 4 have the same first element. Because of this reason, this R3 is not a function. Understood these points, my dear children? Can you identify if a relation is given? If a relation is given, can you identify whether it is a function or not? Yes. Uh, yes, tomorrow I'm planning to take a class, special maths class at 3 o'clock, afternoon 3 o'clock. Because I'm not taking the class at 8:30 every day. Yes or no? Here in this week, I have not taken from 8:30 to 9 because we are getting hardly 15 minutes or 20 minutes only. We cannot cover that. It is not sufficient time for us to discuss the points clearly. So that is why I'm planning to take a special maths class tomorrow, Saturday, every Saturday, hereafter every Saturday. Okay, my children, at 3 o'clock, at 3 o'clock, 3 to hardly 1 hour, hardly 1 hour or 1.5 hour, 3 to 4:30, hardly, maximum, 1.5 hour. Okay, my children, are you ready to attend the class? Mahima, Samuel, Richard, Catherine, Juice, Percy, Nikhil, tomorrow at 3 o'clock, afternoon 3 o'clock. Okay, my children, 3 o'clock to 4:30, 1.5 hour only. If you are not taking extra classes, we cannot complete the syllabus. We are going very slowly, very detailed manner. That is why I am taking special classes. Okay, my dear children. Now the time is 9 past 47 minutes. Now you can leave the meeting. Take rest. Take care of your health, my dear children. Stay at home. Stay safe. Sanitize your hands frequently. Maintain social distance of 2 meters from others. And do your duty sincerely and seriously.